So in this session of m squared m cubed or 2, Mrs. M's Math to the Masses in a minute or two, we're going to look at compound events. And there's two types. There's independent events when the outcome of one event does not affect the outcome of another. And in this situation, we will multiply to get our answer. And we'll just multiply the two events together. But in dependent events, which we'll work in the next session, it's when the outcome of one event does not affect the outcome of another event. So this is going to be the probability of the first event called A, and we'll multiply it times the probability of event B, and we're about to work examples of this. The next video will talk about the probability of event A, but the probability of the second event is B after event A has happened, and we'll look at that next. So for independent events, our first example is about a die. It's being rolled 3 times, and what's the probability of getting 1s on each roll? So you have a 1 in 6 chance the first time, a 1 in 6 chance the second time, and a 1 in 6 chance the third time. You multiply everything together, and you say there's 1 out of 216 chance of rolling a 1 3 times in a row. You change that fraction to a decimal, and it is 0.005. When you multiply times 100, that is a 5% chance. So your answer is depending on if you want fraction, decimal, or percentage. The next example is a coin being tossed. Then a day of the week is selected. What is the probability of getting tails? Then a day starting with the letter T. So you have a 1 in 2 chance of getting tails. We'll call that our coin probability. And we'll multiply that times our probability of getting a day of the week that starts with T. There are 2 of the 7. So we get a 2 over 14, which reduces to a 1 in 7 chance. As a decimal, that's a 0.14. And as a percentage, that's a 14% chance. Okay. Now let's look at examples. We have a bag of red crayons, purple crayons. Get my purple, yellow crayons, and green crayons. Here's green, and here's our yellow. Okay, so you do have to figure out how many total crayons you have. So we know we have 4 green. We had 6 yellow. I'm just going to highlight the 6 in yellow. So remember that was representing that. 14 purple. And we had 8 red. So if you add all those crayons together, your total sample space has 32 crayons. So we have to come up with the probability A and multiply it times the probability of B. So since there's 14 purple, we have a 14 out of 32 chance of drawing a purple. And the next color they said was then yellow, which is a 6. Multiply times 6 out of 32. And just multiply your numerators together and multiply your denominators together. You get a 21 out of a 256 chance, which reduces to 0.08, which then becomes an 8% chance when you multiply by 100. Didn't realize that was off camera, so I'll bring that up here so you can easily see the 14 out of 32 for purple, 6 out of 32 for yellow. Multiply the numerators and denominators together, change it to decimal, multiply 100 to get the percentage. So the next example, they want to know green then red, that probability. So green, we have 4 greens. So 4 out of 32 chance of getting green. Then red is an 8 out of 32 chance. When you multiply that together, you're going to get 1 over 32, which becomes 0.0 3, or about 3%. Now it says 2 purples. So we know purple is a 14 out of 32 chance, and we're doing that twice. And we multiply that together, we get 49 out of 256, which equals 0.19, multiply times 100, a 19% chance of getting 2 purples in a row. And 2 yellows. We know yellow was a 6 out of 32 chance the first time and 6 out of 32 chance the second time. So you end up with 9 out of 256, which is 0.035, which is about a 3.5% chance. This is a chance of getting yellow and getting yellow because they asked for 2 yellows. Those are some examples of independent event calculations.